Today I just want to teach us how to repair a stabilizer with this AFR board. This one is for 5,000 watt, 3,000 watt, then this one is for 2,000, 1,500 watts. So how to repair a stabilizer with this AFR board? It is quite easy. Please, I'm begging you, help me share this video with anybody, any technician that is doing this job, that is repairing stabilizer, that there's a solution to it if the board is totally dead. Instead of condemning stabilizer or throw it away, there's a lasting solution to it. The board can be replaced, and this is the board. And today I just want to show us how to repair a stabilizer. So today I want to repair this Century stabilizer. This is a common stabilizer in Nigeria. This is a Century. This 2,000 watt, 2,000 feet stabilizer. Firstly, I have to remove the dead board. This board is dead already, so I have to remove it from the stabilizer from the. So this is the dead board now. So I want to replace it with new one. So, but firstly, after you remove the dead board, you have to know, identify the tap very well. This transformer is quite easy to study. It's quite easy to study. Clearly looking at this transformer now, clearly looking at it, this is the first tap because it's the innermost tap of this transformer. This is the first tap, followed by the second tap, followed by the third tap, then followed by the fourth. This is the fourth tap now. This is the fourth tap, then followed by the fifth. This is the fifth tap, then followed by the sixth tap. This is the sixth tap. Then this is the last tap. You see the last tap now. See the last tap. This is the last tap of the transformer. So this is the last tap of the transformer. So this is the first. This is the first tap of the transformer. Based on this number now, you insert each terminal according to the number. This board has been numbered. This board has been numbered 1, 2, 3, 4, 5, 6, then 7. So this here is the output, while this one is the input. So quite easy and straightforward. So let's try to solder it together. I've told you that the board have been numbered. So now, from here now, this is the first tap. We will insert the first tap here. See, you insert it here. That's the first tap. The second tap now, you insert it here. See, this is the second tap. This is the second tap. The third tap, insert it here. So this is the third tap, you insert it here. So the board has been numbered, don't forget. So it is easy. So this is the fourth tap, you insert it here. This is the fourth. Then this is the fifth tap. This is the fifth, you insert it here. See, it's very easy. This is the fifth tap. Then this is the sixth. So this sixth tap will go to here, not here, not here, not here, but here. So the sixth tap will go come here, insert it here. But the seventh tap, this is the last tap now. We now insert it here. You insert the seventh tap here. Then you solder. So that's the first step. Let's solder all the taps now that we have inserted on the board. So now we have soldered all the board. all the tap together on the board now. So then you now look for the output wire, the wire that's supplied to the output socket here. This socket, they are supplied to the live. So there are two wires here. One is live, one is neutral. So you look for the live. So this is the live. If you look at it very well, it's connected to this live from here. This is the live, so it's a lot of supply here. So now this is the supply wire. You collect it here. So very easy. Then you solder it. Then remain the neutral now. This is the neutral wire. This is the neutral on the second tap, and it's the one that comes from the power supply. So this is the neutral. Now collect the neutral with the first tap. Collect the neutral with the first tap. Then let's solder it. This is the first tap. Do not forget this is the first tap. So there's a port there. You solder the neutral. Now the live come after the switch. This is the on and off switch. This is the switch. See it very well. This is the on and off switch. This switch on and off. So the wire is this live that will supply the board for the from the main, from the NEPA. When you plug it to any power supply. Now you have to solder the indicator. This is the power indicator, this is the delay indicator, and this is the delay button to the board, to this board. So then also we have to remove this wire. We have to disconnect this wire. So let's try. We'll disconnect this wire first so that we have disconnected the wire. Then this resistor on board here, we'll desolder it because the resistor needed to connect with this LED bulb, the resistor is on the board already. So we don't need this resistor again. We have to disconnect it. Do not forget that this is the power indicator in use. Then this is the delay indicator. Then this is the delay, but those are the three items we need here to connect to the board. This wire, you have to identify the positive of the LED bulb here. These two LED bulbs, the positive and the negative. Then the two terminal here. So these two terminal, the two terminal for the switch will be connected to the board. The two terminal for the LED bulb for the delay indicator will be connected to the board. The two terminal for the in use as power indicator will also be connected to the board. So you have to identify them. So now this wire come from the delay button. This wire from the delay button. Then we have to attach it with the delay button, delay port on the board. We attach it to the delay port on the board. Then after that, this is the ground. This is the ground cable on the board. Collect it here. This wire now is the delay indicator for delay indicator. Then you collect it to the board. This one now, we solder it to the power indicator, the positive. Then the next thing, so here now, on the board, since we have removed the resistor attached to this delay indicator, we have to bridge the negative terminal to the ground on the board. This wire now, this for output meter, see it clearly, this for output meter, we have to solder this wire to the output, and this is the output here. You have to solder it here so that it indicates the output voltage. Solder the second terminal of both meter to the neutral. We have to solder the second terminal of both input and output meter to the neutral. And this is the neutral wire. So now let's try to test this thing. After we have this is the cable to the start. You can see it clearly. This is the cable to the start. So let's try and plug it to our electrical socket and see maybe the board will come up or not. Let's try and connect it to the electrical outlet. So now I want to test this board now. So I've connected the stabilizer to the board. So I want to turn on this thing now. You can see that the LED indicator is now flashing and the power indicator is on. So the LED indicator is flashing. Now one thing here is this: if this LED indicator is slow like this, it means the board will wait for 99 seconds before it supply any voltage out. You can see it here. It's only the input meter that is showing the input voltage now. So this LED is blinking slowly. It means after 99 seconds, the board will now supply the voltage to the output. But if we press this delay button now to change the time, it will now change to 5 seconds. You can see now the LED is now flash. It's now somehow fast. So it's now fast. So it will be after 5 seconds, as you can see. After 5 seconds now, the board will supply out. So you can see that the output meter is now working now, meaning that the board is okay. So please help me share this video with any technician you know, or anybody that is facing this challenge, that there is a solution. Instead of condemning the staff, instead of condemning the board, instead of throwing it away, so there is a solution to your stabilizer problem. If you have issue with stabilizer, these are the board. You just buy it and replace the dead one. So thank you and God bless.